Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is 9231 Further Probability and Statistics, the specimen paper for the 2020 exam series, question 6. Aisha has a bag containing 3 red balls and 3 white balls. She selects a ball at random, notes its color, and returns it to the bag. The same process is repeated twice more. The number of red balls selected by Aisha is denoted by x. A, find the probability generating function of x. I'll begin by creating a probability distribution table. I don't need the table for the requirements, but it helps me to organize my information. So I want to know for x, what's the probability that x is a particular value? And since we're going to select 3 times, we select and then we select twice more, so we're selecting 3 times. So the maximum possible number of red, which is what x represents, is 3. We couldn't get 4 if we only select 3. But we could get 0 or 1 or 2 or 3. The probabilities for these are on the ends, 0 red or 3 red are 1 over 8. Those would have to be white, 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 or red, red, red. And those possibilities are 1 over 8. In the middle, either getting 1 red and 2 white, or 1 white and 2 red, those are 3 over 8. As an example of 1 red and 2 white, there are 3 ways to do that. Red, white, 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 red, white, 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 red. Notice that these 4 probabilities sum to 1. 1 plus 3 plus 3 plus 1 is 8. 8 over 8 is 1. Your sum of probabilities should always be 1. And with this information, I can create my probability generating function. I'm going to use terms of increasing powers of t from t to the power of 0 for the first value, then t to the power of 1, then t to the power of 2, then t to the power of 3. This is my probability generating function. Now we'll continue to requirement B. Basin also has a bag containing 3 red balls and 3 white balls. He selects 3 balls at random without replacement from his bag. The number of red balls selected by Basin is denoted by y. B, find the probability generating function of y. Here I'm also going to create a probability distribution table for the variable y. I'm looking for the probability that y is a particular value. In this case, we're also considering 0, 1, 2, and 3. Maximum number of red balls to be selected with 3 picks is 3. The difference here is that there is no replacement. And this is going to affect what the probabilities end up being. On the ends, we're going to end up with 1 over 20, 1 over 20. And either 1 or 2 red will each be 9 over 20. And again, you can add those to confirm that you arrive at the total probability of 20 over 20 or 1. Again, like A, I'm not working through the detailed probability calculations. You can do that. And with my probabilities, I can again create my probability generating function using ascending powers of t. 1 over 20 plus 9 over 20 times t plus 9 over 20 times t squared plus 1 over 20 times t to the power of 3. Let's continue on to requirement C. The random variable z is the total number of red balls selected by Aisha and Basin. C, find the probability generating function of z, expressing your answer as a polynomial. This calculation is to find the probability generating function. I want to multiply the individual probability generating functions, which we created in parts A and B. And the setup is 1 over 8 plus 3 over 8t plus 3 over 8t squared plus 1 over 8t cubed times 1 over 20 plus 9 over 20t plus 9 over 20t squared plus 1 over 20t to the power of 3. And there's a bit of expansion and simplification involved. When that's done, I end up with 1 over 160 times 1 plus 12t plus 39t squared plus 56t cubed plus 39t to the power of 4 plus 12t to the power of 5 plus t to the power of 6. And let's finish up with requirement D. D, use the probability generating function of z to find the expectation of z and the variance of z. I'm going to set up a probability distribution table using the probability generating function from part C. I'll pause and post that on the screen. Here's my table. For expectation, I want to multiply the possible outcome times the probability to synthesize the writing. Notice that all of the probabilities are over 160. So I'm going to take 1 over 160 outside, and I'll multiply all of my multiples by 1 over 160. So the probability of 0 is 0 times 1 over 160, but I've taken the over 160 outside, so I'll write 0 times 1. Plus, the probability of 1 is 12 over 160. Here I've taken the over 160 outside, so I'll write 1 times 12. Plus 2 times 39, plus 3 times 56, plus 4 times 39, plus 5 times 12, plus 6 times 1. So I sum the multiples in the brackets, divide by 160, or multiply by 1 over 160. My expectation is 3. And now for variance, I'm going to put up the formula, then input values. I want the second derivative of the probability generating function with an input of 1 plus the first derivative with an input of 1 minus the square of the first derivative with an input of 1. The first derivative, going back to requirement C, the first derivative of the probability generating function, for now, using the variable t. My first term, I have 1 over 160 times. My first term was 1, that goes away. The next term was 12t, that becomes 12. The next term was 39t squared, so that's 2 times 39t. Then 56t cubed, so that's 3 times 56t squared. Then 39t to the power of 4, 4 times 39t cubed. Then 12t to the power of 5 will be 5 times 12t to the power of 4. And then t to the power of 6 will be 6 times t to the power of 5. And with an input of 1 into the first derivative, the output is 3. For the second derivative, you can take the derivative of the derivative to get the second derivative, and then when you use an input into the second derivative of 1, the output is 36 over 5. And with those values, I can finish up my variance calculation. So I want the second derivative of g with an input of 1. That value is 36 over 5. I want to add the first derivative with an input of 1. That value is 3. And I want to subtract the square of the first derivative with an input value of 1, which is 3, which simplifies to 6 over 5. This completes the requirements for Part D, and this completes the requirements for question 6.